universal shift register. In the previous class, or I was talking about shift registers. So we talked about different categories of shift registers: serial in, serial out, serial in, parallel out, parallel in, serial out, and parallel in, parallel out. And you can see how many clock pulses are required to get the data at the output. So next is, and those were all you can say unidirectional shift registers, where we are just shifting the data on one side only. Now we can categorize our shift registers in you can say in another way, which is called bidirectional shift registers, where the data can be shifted on the right side as well as on the left side. So one type of bidirectional shift register is a universal shift register, which is a shift register where you can, for one you can say type of select lines, there is no change at the output of the flip-flops. On one you can shift the data right, on one you can shift the data left, or you can parallelly load the data into your shift register. So it is actually performing 4 operations. So what all those operations are, that you have 2 select lines and the operation to be performed is written over here on the as the output. So if both the select lines are 0, there is no change at the output. If it is 0, 1, it is shift right, shifting operation, shift right. That means data will be shifted towards right. It can be serially in or parallelly in. If it is 1, 0, it will be shift left. And if it is 1, 1, then parallelly load the data. So these are the 4 operations which are to be performed. That means to perform these selections, you need a 4:1 multiplexer, which will be given to the input of the flip-flop. Then what is the actual block diagram of a universal shift register? We have 4 outputs. Four inputs, a clock, clear bar, a serial in, serial shift, and you will have a shift left, shift right. Then you have 2 select lines, S1 and S0, which will select the operation. So these are the inputs. So this is the actual block diagram of a shift register. It's a 4-bit universal shift register. Anything which is missed out will show it, we'll see whatever is missed out. So first is we'll have 4 muxes. These are the inputs of 4 muxes. So on I3, you can say when it is 1, 1, it is actually loading the data parallelly. So on this we have, you can load the data parallelly. So since it's a 4-bit universal shift register, we will require 4:1 mux. there are two select lines which will be given to both S1 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 and S1. Then we have S0 and this is the output actually. Then we have a D flip-flop. And to all the four D flip-flops, there is a clock which will synchronize all the four flip-flops. It can be negative edge triggered, it can be positive. So this is how it is negative edge triggered. And there is a clear which will reset the flip-flops. So when it is 0, it will reset all the flip-flops. This is what we have drawn. We have 4 flip-flops, we have 4:1 muxes. There where the mux decides with the help of select lines which operation is to be performed. Then we have mode, this is actually your mode control. So your output Z0, Z1, Z2 and Z3 of each, this it is fed as an input to this one. Output of a multiplex. This is output of a multiplex. there is a dot, that means there is a connection. This is how they are connected. So if you have 0, 0, let's study this. If you have 0, 0, so this will be selected, this will be selected, this will be selected, this will be selected. So whatever is the value of input here at this point, it will go to D0, D1, D2, D3. And how do this is selected? It is same as Q0. What is this? It is same as Q1. What is this? It is same as Q2. And what is this? It is same as Q3. So here you have Q0, Q1, Q2, Q3. So when a clock pulse occurs, your output will be same as the previous value. So there is no change at the output. Then we select the line 0, 1. S1 and S0 is 0, 1. If you select 0, 1, then this 1 will be selected from each. That means it should perform shift right operation. So when 1 is selected, this output is something, any 1 or 0. What is this? What is this? It is the value of Q0. What is this? It is the value of Q1. What is this? It is the value of Q2. So when a clock pulse occurs, at the output of Q0 you will have this serial input. At output of Q1 you will have Q0. At the output of Q2 you will have Q1. and at the output of Q3 you will have Q2. So this is a simple shift right operation. Now when we select S1 and S0 to be 1, 0, so it will, according to the mux, it will select this one, this input, this input, this input and this input. What is this input? This will be a input from this side. Let this be 0. This is 0, so this is 0, so it will give D3 to be 0, Q3 will be 0. What about this 2? This is actually Q3. Q3 comes over here, so this value will be Q3, this is Q3, so output of Q2 is equal to Q3. Shift over right. Here it will be 2, it is, what is 2? It is Q2. What is Q2? This is Q2. This will be Q2, this will be Q2. So on that clock edge, this value will be again Q2. So वो shift होके यहाँ आ गया. And this is Q1. Q1 comes over here because mux only transfers the data from input line to output. Q1 comes over here. So the input of D0 is Q1 and on that clock edge, output Q0 will be equal to Q1. So all the data from the right has been shifted towards left. And the last is when both the selection lines, they are 1, 1. So they will have data from parallel loads. You can change it also. There is not necessary that you work like this. So there will be parallel loading. All the data, whatever you load at I0, I1, I2, I3, they will be loaded at these positions. They will go as an input to D and on the clock edge you will get the output. So that is parallel loading. Parallel in, parallel out. So you are serially inputting the data, serial output. Serial in, parallel output. Parallel input the data, parallel output and parallel. So basically you can perform all sorts of functions on this. So this was a universal shift register which is being used wherever you want to perform these 4 operations. 0, 0, and there is, you can design your own. It is having a clock, clear bar to reset the flip-flops, these 4 inputs for parallel loading, shift left and shift right operation for serially inputting the data, S1 and S2 as select lines, control lines, and these are the 4 outputs at the top. So these are the parallel inputs. And these are the parallel outputs. Parallel inputs, parallel output. Serial input, parallel output. Serial input. So this is what is all about a universal shift register. So this is a bidirectional shift register. Now if you see that what applications we are using shift registers. So first application was as a serial to parallel data converter. Second is parallel to serial data converter. For storing the data, if you want to give that data to some other digital system, you can store it in the shift registers and give it to them serially, parallelly, anyway. Then there is another use of shift registers, you can use them as counters. We have shift register counters like a ring counter, and then you have a twisted ring counter. We'll talk about them also, but there's a ring counter, there's a twisted ring counter. So you can design those counters using shift registers. But this is one more application of a shift register counter. Another one more application for a shift register counter is a UART. UART. The first was serial to parallel converter. Second was parallel to serial converter. These are the applications of shift registers. Then to use it as counters, you can design shift register counters such as such as ring counter. We'll talk about these also, ring counter and twisted ring counter. These are used for creating lightning effects, both the counters. Then the fourth is, it is used as a UART. It's universal asynchronous receiver transmitter. So wherever you want to convert your data from serial to parallel, because basically in our digital systems, you normally do the processing in parallel. You take the data parallelly and do the processing and give the data back parallelly. But from our daily day-to-day work, we just have data in serial order. So what you do is you use a shift register, take the data serially, convert it into parallel, feed it to the digital system, do the processing, get the data parallelly and again convert it into a serial fashion. So this is what a UART, Universal Asynchronous Receiver Transmitter. So these are the applications of shift register counters, which are very important. You should know if somebody asks you that what are these applications and where do you use these shift registers. So this is the place. And generally you know that D flip-flop is one which only stores the data and gives you the same data after some delay. So another one most important is the delay. So these shift registers gives the delay to your signal. If you want that to the next system, both the signals they should appear at the same time, and one is appearing early as compared to the other. So you can give a delay to that using a shift register. So this requirement so that both of the signals get synchronized, you give a delay to that signal. So another important factor of a application of a shift register is a delay. So if you want to give a delay to your signal so that both the signals they approach at the same time to the next system, you can make use of shift registers. So thank you. This was all about shift registers. In the next class, we'll talk about the counters, the types of counters and how to design the counters. Thank you.